In transpose of a matrix, we will look at how to do transpose of a matrix, then properties of it, and few problems on transpose of a matrix. Please like, share and subscribe this particular channel. Let us start now. Come to transpose of a matrix. If we have a matrix like A, okay, then we represent transpose of a matrix as A power T or A dash. What is a transpose? Transpose is nothing but interchanging the row and columns index of each element. Okay, if A contains complex elements, then A transpose does not affect the sign of the imaginary part. If you consider an example, like if it is an A matrix is equal to 1 2 0 5 4 minus 3, it is a 2 cross 3 matrix, right? It is a row, this is nothing but a column, right? Now in transpose, row would be converted to column and column would be converted to row. So when you're changing the row 1 2 0 to a column 1 2 0, right? Then it becomes nothing but 3 cross 2 matrix, right? If you consider one more example, like here there is a complex elements, right? Now there would be no sign changes. If you consider this one, it is a row 1 2 minus I 1 plus I, right? And it is being converted to column, then sign changes would not be changed. Now A is 2 cross 3 matrix and A transpose is 3 cross 2 matrix. Now coming to conjugate transpose or Hamilton transpose. Okay, first we'll understand this one. Hamilton transpose of an M cross N matrix within a complex entries is the N cross M matrix obtained by taking the transpose and then taking the complex conjugate of each entry, right? Now they are saying that we'll be converting M cross N matrix to N cross N matrix by taking two steps, transpose and complex conjugate. First we'll understand what is meant by complex conjugate. Okay. Here something number like z is equal to 3 plus 2i. Then z bar is equal to 3 minus 2i, but we change the sign. It is called as a complex conjugate. Right. Now how do we represent? The Hamilton transpose is nothing but it's given by A star or A theta or A conjugate then transpose, right? We are doing two steps, conjugate and then transpose. I'll be giving one example for better understanding. If A is equal to 1, 2 minus I, 1 plus I, 5, 3 plus 2I and 4. They are three complex numbers here, right? And it is nothing but 2 cross 3 matrix. Then we'll be doing Hamilton transpose is given by 1, 2 plus I, 1 minus I, 5, 3 minus 2I and 4, right? What do I doing here? Will be sign changing 2 minus I to 2 plus I, right? Then 1 plus I to 1 minus I, 3 plus 2I to 3 minus 2I. Row is changed to column. Then it becomes nothing but 3 cross 2 matrix. Now coming to the properties of transpose, both normal transpose and conjugate transpose. Okay, first only looking at normal transpose. If you consider the first one, k is nothing but constant term or a scalar value. A is in a matrix. Whole transpose is equal to k into A transpose. And A has been transposed twice. So it is equal to nothing but A only. Again, we are adding two matrices A and B. Whole transpose is equal to A transpose plus B transpose. Again, we'll multiply A and B whole transpose is equal to B transpose into A transpose. Now coming to the second one, nothing but conjugate transpose, where K is nothing but complex number, A is nothing but a matrix. Whole will be doing conjugate transpose, which is equal to nothing but K value would be doing the conjugate and will be multiplying with the A such that it is nothing but conjugate transpose. Again would be A would be doing 2 times conjugate transpose. Then it is equal to nothing but A only. Then when you add two matrices and doing a conjugate transpose, then it is equal to A conjugate transpose plus B conjugate transpose. When you multiply A and B and do a conjugate transpose, it is equal to nothing but B conjugate transpose into A conjugate transpose, right? One of the note point that you have to remember is nothing but diagonal elements position does not change in the case of an transpose of an matrix, right? Now coming to the question. Given the matrix J and K, then the product of K transpose J and K is how much? We have to find out. So they are asking for the value of K transpose J and K, right? So first we'll be writing all the values. K transpose, okay? K is nothing but 3 cross 1 matrix. So when you do the transpose, then it becomes 1 cross 3 matrix. So it becomes nothing but 1, 2, minus 1, right? That is nothing but 1 cross 3 matrix. Then this one is multiplied with the J matrix, right? It is nothing but 3, 2, 1, 2, 4, 2, 1, 2, and 6, right? Again, it is 1, 2, and minus 1, right? So just we have to multiply all of them. This one is 3 cross 3 matrix. This is 3 cross 1 matrix. It's nothing but J matrix. It's a K matrix. And it's a K transpose, right? First we'll be multiplying these two, J and K. Then we get K transpose is nothing but it becomes 1, 2, minus 1, right? Again we'll be multiplying these two values, right? So it becomes 3 with a 1. So it becomes 3 plus 4 minus 1. Again you're multiplying it. It becomes, there is nothing but 2 plus 8 minus 2, right? Again this one is nothing but 1 plus 4 minus 6. Just we are multiplying both of them, right? So it becomes 1, 2, minus 1, right? It's nothing but K transpose, right? It is nothing but JK, right? It is a K transpose. And again we will be multiplying it. So it becomes nothing but, its value is nothing but 6. It's 8. And this is nothing but minus 1. Just we are multiplying it, right? So again you multiply it, it becomes 6 plus 16 plus 1, which is equal to nothing but 20. So answer is nothing but option 23. For matrices of side dimension m and n and scalar c, which of these properties does not allow hold? Okay, the first one is m transpose whole transpose. 2 times they are doing the transpose. This is an m, so this is correct. C is nothing but a scalar multiplied with an m matrix whole transpose. So C would be coming out m transpose is also correct. And we are adding two matrices m and n. Whole transpose is equal to m transpose plus n transpose. This is also correct, right? M into n is equal to n into m. It's wrong, right? It's not equal to. So answer is option D.